So when the web started, people talked about web sites. Sites were usually static content, text and images and things like that. And sites quickly evolved to be services, which is really more where we are, where really there's a program that's running and the web browser and using URIs to get stuff at it really just become a way of accessing the program. And then service-oriented architecture sort of developed as a way of saying, well, if we can do that, why can't we have multiple different web servers that essentially are collaborating to put together the overall experience? So let's talk a little bit about how that all works. So if we start from Web 1.0, as I'll call it, sort of in the early 1990s, the world was pretty simple back then. You would be sitting at your browser and you would make a request to some web server. Let's say it's an HTTP GET to get some information. What would come back from that usually is an HTML document. Here's a simple HTML document that it has some text. It has a form on it. Oh, and maybe the document also had things like embedded images. They were really cool when embedded images first appeared on the web. They weren't always there. So if there's an embedded image, the browser will find that tag and say, oh, okay, let me go get that image. And I will display the image as part of the page. That's all good. So now I have my login form. Now as a human being, I'm going to type in my password. And your homework is to figure out what that password is a reference to, by the way. And I will submit. What happens when I send this form with my password or whatever up to the server? Because now the idea is that this means that I should log in. Well, typically, I would do a post. Remember, post usually has the semantics of, I'm going to send information to you or we're going to do something that changes the state of the world. So in this case, both are true. I'm sending information in the form of my password and maybe some other information like my username. And it's going to change the world in that now I'm logged in and the server has to somehow remember that fact. What would usually come back from that in the old days was just another HTML document that would replace the one that I had just been looking at. So there would be basically, every time I did a request to the server, unless it was for something like an embedded image, every HTTP request resulted in a brand new page being displayed as if it were brand new. And you can see, now that I've hit the login page, the text is different and there's like a little nice message. And maybe even it's going to load a new image that is the icon that I see when I'm logged in. Right. So this is how the web used to work. And one of the improvements that came in the late 1990s was that after I had gotten the initial page, there was an additional possibility for how the user could interact with it. In particular, if that page had embedded in it or had separately loaded some chunk of JavaScript code, that JavaScript code had the ability on its own to make a request to the server. So in this case, I'm going to type in my password again, but instead of doing a form submit that results in a new page load, I'm going to separately send that information to the server, possibly via a post again. But it's this little piece of JavaScript code that I wrote that is doing that post. It's not the browser itself that's doing it. And eventually the server will come back with a reply. And the reply will typically be some sort of a data structure. In the old days, it was assumed that XML was going to win the battle for the interchange format. As we'll see, it's actually changed over to being JSON. But the basic idea is the same. You would get a hierarchically oriented machine-readable data structure. Your JavaScript code would be handed that data structure, and it would look at the data and figure out how to modify the existing page in place without loading a whole new page. So for example, it might use this to replace the splash message with something that shows your login name. It might even decide to replace the login image. It could make a request to the server saying, oh, get the new image. And when you get it, replace the existing piece of the page with the new image. So this was a really big deal because for the first time, the act of communicating with the server and getting stuff back became separated from the act of having the whole page being rendered. Suddenly, you could sort of modify the page in place as things were happening. And this ability actually appeared for the first time, excuse me. And this ability actually appeared for the first time in 1998 in Microsoft Internet Explorer, which was the predecessor browser to Microsoft Edge. And this is the piece of the machinery that sort of makes it all happen. The stuff in the box, which is the ability of JavaScript code to separately do requests to the server, to receive data from the server, to make decisions based on that data about how to modify the page. That sort of collection of behaviors was collectively called AJAX for asynchronous JavaScript and XML. And even though XML is rarely used these days as the way that data is returned, we still generally call it AJAX. So the higher order way that this works is the browser had to be modified to provide JavaScript language bindings. In other words, you need a way from JavaScript to initiate the same HTTP requests to a server that the browser would normally do on its own, right? So this had to be exposed to JavaScript programmers so that they could include it as part of their page. And not only that, when the server returns data, there needs to be a way for the browser to find the piece of JavaScript that is supposed to receive it and say, here, this is what the server returned. Now go do your thing. And as we'll see later on in the course, there's a third thing that the browser has to provide, which is a way for JavaScript to interact with the page itself so that JavaScript could make changes to the page content without sort of just having the browser render a brand new thing. And as I said, even though it's called asynchronous JavaScript and XML, nothing about this is XML specific. The server can return whatever it wants. The client and server can have any agreement as to when JavaScript makes a call, what kind of data is going to come back. It's just that at the time, the main interchange format for data across computers was XML. So there was an assumption that this is probably what we're going to use to communicate across services also. So this led to the idea of a microservice, which is something that you can't really do without Ajax. A microservice is basically a little independently deployable SaaS that supports message-based communication. And that means that it's something that might not be designed to be called from the top level. It's not something whose URL you could type into the browser and expect something sensible to come back. In fact, it might only be designed to ever return data structures because it's designed to only be called by another program to sort of construct part of a page. A big obvious example in a lot of today's websites is something like Stripe. It's a payment processing service. If you go to stripe.com, you'll just see the Stripe website and instructions for developers. But Stripe itself, the part that actually does payment processing, is only designed to operate over an Ajax-like interface where it's designed to be called from JavaScript. A specific call is made that will trigger a payment. A data structure comes back describing what the result was. It's not designed to be a standalone website. It's designed to be a service. And that means that a lot of them can really specialize what they do. They only provide part of the functionality of a site and are highly specialized for one narrow task. And if you think back to what makes Agile so popular, what are the kinds of projects where Agile development works particularly well? Well, small to medium projects tend to do better in Agile than very large ones. That's great because a microservice, because it's so specialized, can be small. It can be managed by a pretty small team. The same team that builds it typically is running it. So that means that the developers are close to their customers. They can react rapidly to what the customers say they want, and they can make quick enhancements because there's no big distance between the people doing the programming and the people who are running the service, keeping it operational. It's an obvious way to compose a lot of small subsystems into a larger service, like the bookstore we talked about in the Agile example from the first chapter. But there's as always, there's a downside or some downsides. First of all, if you're assembling a page from a lot of different pieces, your page load time can now be affected by the slowest of those pieces. I'm sure we've all had the annoying experience where a page loads and you're about to click on something and then it moves because something else just got loaded and the page had to be redrawn to make room for it. Some of those problems can be solved to a certain extent with good graphic design, good layout of the page. But fundamentally, if your page is being put together by a bunch of different pieces that are all replying at different times, the idea of page load time becomes harder to get your hands around from a performance standpoint. You also have to manage partial failure. If your single SaaS app is serving everything on the page, either your app is up or it's down. But if your page has components that are being served from a dozen little microservices, you have to be prepared for the possibility that any one of those might temporarily fail. And what are you going to do? Do you display a broken icon? Do you just remove that part of the page? So you have to think about partial failure in a different way. There's also more interfaces to keep track of. Remember that the contract, so to speak, between how to interpret a URI is just between the client and any particular service. So now, as a developer, you're not just worried about how are URIs interpreted by your SaaS app. You also have to have information in your app about communicating with other services and how they expect to interpret URIs. Fortunately, REST helps a lot, and we're going to talk about that next, as an organizing principle that many sites follow when they're doing their Ajax APIs. And finally, it used to be that developers wrote code and operations people kept the code running. But with a microservice model, it's much more common that everyone does a little bit of both. That's what's called DevOps, or developer operations. So each side sort of has had to learn more about the other side, but I would argue in a small team setting, that's not a bad thing. It means more people have more knowledge about debugging different aspects of the service's failure. So that's a sort of exposition of what's a microservice and how it is that adding asynchrony to the original web specification essentially makes that possible.